Hello everyone, welcome back to my channel Akshara Tutorial. I am going to discuss about Newton's third law of motion. This is laws of motion part 3. Newton's third law of motion statement. To every action there is always an equal and opposite reaction. That means here, for example, firing a gun. Okay, here if FAB, that means force acting on body A and body B. If FAB is the force exerted on body A by body B, this is action. And FBA is the force exerted on body B by body A. This is reaction. Okay, according to third law of motion, what is the statement of third law of motion? To every action there is always an equal and opposite reaction. That means FAB is equal to minus FBA. Negative indicates opposite reaction, opposite direction. Negative indicates opposite direction. FAB means force exerted on body A by body B. FBA means force exerted on body B by body A. Okay, here action and reaction are equal in magnitude and opposite in direction. Okay, and another point is action and reaction don't act on the same body. Therefore, they do not cancel each other. Okay, don't act on the same body. They do not cancel each other. For example, book kept on a table, firing a gun, flight of jet planes and rockets. Rockets also best example for Newton's third law of motion. రాకెట్ అనేది ముందుకు వెళ్తూ ఉంటే దాని వెనకల పొగలనేవి చిమ్ముతూ ఉంటుంది. దట్ మీన్స్ దట్ రాకెట్ మూవ్ ఫార్వర్డ్ డైరెక్షన్ that gases, that means waste gases exerted on outward direction, that means opposite direction. This is important example for Newton's third law of motion. Okay children, another important topic, impulse. What is impulse? The product of force and time that produces a finite change in momentum of the body is called impulse. What is impulse? Actually, the product of force and time. This product of force and time produces a finite change in momentum. How is it? That means find out the formula. Impulse, it is defined, it is denoted by J. Impulse denoted by J. Impulse is equal to force into time, the product of force and time. Force means ma, this is the formula ma. Time is t, mat. Here already we know that acceleration a is equal to final velocity, the differences between final velocity and initial velocity with time. Okay, m into v minus u by t into t. T are cancel. What we get? M into v minus u. mv minus mu. That is change in momentum. Okay, it produces change in momentum. This is the definition for impulse. This SI units or J is equal to mv minus mu. Already we know that momentum units kg meter per second or Newton into second. This is also formula for SI units. Dimensional formula is mlt minus 1. It is a vector quantity. Next topic is momentum. What is momentum? The product of mass and velocity of a body is called momentum. SI units. P, it is denoted by P. This formula is P is equal to mv. SI units are P is equal to kg meter per second. This is units for momentum. Next topic is laws of conservation of linear momentum. Law of conservation of linear momentum. This is also very very important. యాక్చువల్లీ మనకు లాస్ ఆఫ్ మోషన్లో ఐపీ ఎగ్జామ్కి వెయిటేజ్ వచ్చేసి 4 మార్క్స్ అండి. వెరీ వెరీ ఇంపార్టెంట్ టాపిక్. దిస్ ఈజ్ ఆల్సో వెరీ వెరీ ఇంపార్టెంట్ టాపిక్. నెక్స్ట్ స్టేట్మెంట్ ఆఫ్ లాస్ ఆఫ్ కన్జర్వేషన్ ఆఫ్ లీనియర్ మొమెంటమ్. The total momentum of an isolated system of interacting particles remains constant if there is no resultant external force acting on it. ఇక్కడ మనకు మొత్తం మొమెంటం అనేది సిస్టంలో కాన్స్టెంట్గా ఉంటుంది. అంటే ఫోర్స్ అప్లై చేయకముందు ఎంతైతే మొమెంటం ఉంటుందో ఫోర్స్ చేసిన తర్వాత కూడా అంతే మొమెంటం ఉంటుంది. దట్ మీన్స్ ఐసోలేటెడ్ సిస్టమ్ ఆఫ్ ఇంటరాక్టింగ్ పార్టికల్ రిమైన్స్ కాన్స్టెంట్. ఓకే, ఎప్పుడు కాన్స్టెంట్గా ఉంటుంది అంటే ఇఫ్ దెర్ ఈజ్ నో రిజల్టెంట్ ఎక్స్టర్నల్ ఫోర్స్ యాక్టింగ్ ఆన్ ఇట్. ఓకే, ఎక్స్ప్లెనేషన్. హియర్ లెట్ us consider two bodies m1 m2. Okay, two bodies A and B. Their masses m1 and m2, their velocities u1 and u2. During collision, the bodies interacting to each other. Okay, there during collision A and B. After collision, their masses are equal, but their velocities are differences. That means initial velocity is v1, final velocity is v2. This is after collision. Let us consider two bodies of masses m1 and m2 moving in same direction with initial velocities u1 and u2 respectively. Let their velocities are v1 and v2 after collision. Okay, here that bodies, first of all, before collision their momentums. Okay, rate of change of momentum of A action, that is before collision, that momentum is m1 v1 minus m1 u1 by t. Next, rate of change of momentum of B, that is reaction. That means after collision their momentum m2 v2 minus m2 u2 by t. According to Newton's third law of motion, what is the statement of Newton's third law of motion? Action is equal and opposite reaction of reaction. Okay, now that according to Newton's second law, before collision momentum is equal to minus after collision momentum. m1 v1 minus m1 u1 by t is equal to minus m2 v2 by minus m2 u2 by t. Both t's are cancelled. What we get? m1 v1 minus m1 u1 is equal to minus m2 v2 minus m2 u2. Finally we get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. The total momentum before collision is equal to the total momentum after collision. This is the statement of laws of conservation of momentum. This is also very very important for IP exam. Okay children, today this class is concluded.